Hi friends, let us try to understand the images formed by concave mirrors, the next three cases. So if the object is placed beyond C, so in the previous class we have understood that the image is formed depending upon the position of the object. So if the position of the object is at infinity, image is formed at F. If the object is beyond C, the image is formed between F and C. If the object is at C, the image is formed at C. Now in the fourth case, we are keeping the object in between F and C. Where is the object? You can see the object is in the blue line, that is AB. Where is it? It is between F and C. Object is between F and C. Now when the object is between F and C, now you can see the first ray passing parallel to the principal axis. If the first ray is going parallel to the principal axis, if it is parallel to the principal axis, passes through focus. Parallel to the principal axis, passing through focus. And the second ray is passing from the focus. If it is passing from the focus, it goes parallel to the principal axis. So this is passing from the focus, going parallel to the principal axis. Both the reflected rays, this is the reflected ray and this is the reflected ray. Now this is the reflected ray and this is the reflected ray. Both the reflected rays are meeting at a point. Here the image is formed and this point is beyond C. So where is the image formed? The image is formed, that is beyond C. Beyond C the image is formed. Now if you observe the size of the object as well as the image, the size of the image is bigger than the size of the object. If it is bigger than the size of the object, we write it that it is a magnified image. It is a magnified image. Now are the reflected rays meeting? Yes, the reflected rays. This is one reflected ray and this is the other reflected ray. Both the reflected rays are meeting. Because they are meeting at a point, we can get a real image. And you can see the head is down. The first ray is this and the second ray is this. So the head is down here, so it is inverted. So what is the nature of the image that is formed? The nature of the image formed is real, inverted and magnified. Where is the object? Position of the object is between F and C. Position of the image is beyond C and the image is real, inverted and magnified. That is case 4. Now when we place the object at F, if you place the object at F, what is happening? If you place the object at F, again try considering both the rays. The first ray passing parallel to the principal axis. If it is parallel to the principal axis, goes through focus. So this is parallel to the principal axis and passing through focus. And the second ray is making a certain angle with pole. If it is making a certain angle with pole, with the same angle, it will reflect back. So this is the incident ray making an angle with the pole. With the same angle, it reflects back. So this is reflected ray. These two are reflected rays. But these two reflected rays are not meeting. So if you observe the distance at this point and at this point, what is happening to the distance in between both the reflected rays? Here the distance in between both the reflected rays is more and here the distance in between both the reflected rays is less. Means if you extend these reflected rays, they are going to meet at a point somewhere else. So that point at where they meet is very far from this. So you say that the image is formed at infinity. The image is formed at infinity. Now where is the object? The object is at F. The object is at F. And where is the image formed? The image is formed at infinite. Now if you observe these two rays, here the distance is increasing, here the distance is more and here the distance is less. These kind of rays are called as converging rays. Means the rays which are going to meet at a point in future are called as converging rays. These rays are called as converging rays. So they come and meet at a point. So here, because the both rays are meeting at a point, what image is formed? It is real and inverted image is formed. Real and inverted image is formed. Let us suppose if it meets at a point here, if the reflected rays are coming and meeting at a point here, then what is the size of the image? this principal axis will be extended here, and from here to here will be the size of the image. So obviously the image size is bigger than the size of the object. The image size is bigger than the size of the object. So it is called as, it is a magnified image. It is a magnified image. So what is the position of the object? Position of the object is at f. Position of the image is infinite. And what is the image? What is the nature of the image? It is a real, inverted and magnified image. Now this case we will be using in many cases. Like, where do we use this? This is one of the use of the concave mirror. If you take a concave mirror and in your head bulbs of your vehicles or in torches where the object is kept at focus, like if you are using a torch, the bulb of the torch is kept at focus so that the rays go like this and hit the mirror, and whatever are hitting the mirror, they move parallel to the principal axis. They move parallel to the principal axis because the image is formed at infinity. So this is used in headlights. Already, if you recollect the first case is when the object is at infinity, the image is at f. If you recollect the first case, it is the reverse of this. The object is at infinity, the image is at f. Now if the object is at f, the image is at infinity. That is what we need to understand here. And coming to the last case, last one is between P and F. Of course, if you place the object here, there is no reflection taking place because this is only the reflecting surface, and you can find the coating of it is towards this side. Okay, if you place an object here, definitely there is no reflection taking place because this is the reflecting surface. This side is the reflecting surface. So if you keep an object here, there is no reflection. So now the last one, we are trying to understand the image formation when an object is kept in between P and F. Where is the object kept? Object is between P and F. Between P and F. When the object is kept between P and F, you can say the first ray is parallel to the principal axis. Parallel to the principal axis, passes through focus. So this is parallel and passing through focus. And the second ray, you can see, is passing through center of curvature. If it is passing through center of curvature, what happens? It rebounces back. So this is passing through center of curvature and it rebounces back. These two are the reflected rays. Now if the reflected rays, if you see the distance of the reflected rays here and the distance of the reflected rays here, what is happening to the distance? The distance is decreasing or increasing? The distance is increasing. So if you extend the reflected rays a little more like this, will the distance increase or decrease? Obviously the distance will increase. So this kind of rays are called as divergent rays. Means the rays which move far from each other are called as divergent rays. So there is no chance if you move if you extend the reflected rays in this direction. But if you extend the reflected rays in this direction, there is a chance of meeting. So if the reflected rays are extended behind the mirror, they appear to meet. Behind the mirror, they appear to meet. So at this point, an image is formed. This is the same as the image which is formed in our mirrors. So here the reflected rays are not meeting actually. In all the other cases, in all the 5 cases which we have seen, the reflected rays are meeting. Here the reflected rays will meet if you extend, but here the reflected rays will never meet if you extend them. But if you extend them in the backward direction, they are appearing to meet. So here the image that is formed is not real. This is not real. So what is this called as? This is called as a virtual image. And if it is virtual, now you can see AB head is up here, here A dash B dash, because this is the first ray, and here also this is only the first ray. So here this is A, then this is A dash. So if A dash AB is becoming A dash B dash, then there is no inversion. Head is up, here also head is up. So what is it called as? This is called as an erect image. This is called as an erect image, virtual erect. And if you observe the size, the object size is less than the size of the image, or the image size is more than the size of the object, means it is a magnified. It is a magnified image that is formed. And where is the image formed? The image is formed behind the mirror. Where is the image formed? the image is formed behind the mirror. So this is the sixth case. If the object is kept in between P and F, then the image is found behind the mirror. And what kind of mirror, what kind of image is it? It is virtual, erect and magnified image. This image can be used as, means we use concave mirrors for different purposes, and one is it is used as a shaving mirror or a makeup mirror, means, or it is used by a dentist. Like if the dentist want to see your teeth, and if he brings the mirror close to the teeth, means he places the teeth, your teeth will be the object, so your teeth will be placed at a distance less than the focal length of the mirror he uses. Your teeth will be placed, or your tooth will be placed less than the distance of the focal length of that particular mirror, so that your tooth appears very bigger in size, it becomes magnified. The same purpose is the same. It can be used as a shaving mirror or makeup mirror, or it can be used by a dentist. So this case is used by a dentist, or it is used by as a makeup mirror or shaving mirror. So here in this, virtual, erect and magnified images are formed. So these are all the 6 cases of the images formed by concave mirrors.